Problem number 5. This one is very similar to the previous one, number 4. So we need to rewrite the fraction general term of this expression in more convenient way for us to do the calculations. So it's a sum of sequences where Fn is a Fibonacci sequence. So you get like 1, 1. So like when you do the Fibonacci sequence, it's something like this. First two terms are ones, and then you get the sum of these two, 2, last 2, 1 plus 2, 3, and then 2 plus 3, 5, 3 plus 5 is 8, and 5 plus 8 is 13, and so on. It goes to the infinite. So probably at this point, I think you already know what's Fibonacci sequence, but the idea is to get some alternative form of this general term of the sequence that should simplify our expression. So let's look at Fn. Let me write the formula for this using these three terms. Fn plus 1 is obviously equal to Fn plus Fn minus 1, right? The sum of previous two terms. Or it's the same formula, but with the formula for Fn plus 1. So what will be the expression for our general term of the sequence here? Multiplied by Fn plus 1. So let me do the following. Instead of Fn, let me reorder this. Find the formula for Fn. Fn is Fn plus 1 minus Fn minus 1. If I just take this to this other side. So instead, I will replace it, Fn with Fn plus 1 minus Fn minus 1 over. So here we have a multiplication product. So in the general term of the expression, we had 3 Fibonacci terms. Now we have only 2 Fibonacci terms. So that's kind of simpler. Or if I rewrite it like this, so here it's like, I think you can already see that. So if I write it Fn plus 1, so like 2 separate fractions, Fn minus 1 by Fn plus 1, subtract Fn minus 1 by Fn minus 1, Fn plus 1. So here Fn plus 1s get cancelled, here Fn minus 1s get cancelled. So my initial expression is equal to 1 over Fn minus 1, 1 over Fn plus 1. So this expression is basically the difference of reciprocals of these two Fibonacci numbers. So that gives me some kind of convenience to do the calculation, right? I can rewrite my this expression as follows. These are two Fibonacci terms, so I can write it as like 1 over 1 minus 1 over 2. And then for this one, it's like 1 over 1 minus 1 over 3. And then the next one is going to be, so the next term is here should be, so let me write that next term. So that should be the next Fibonacci term over 2 times 5, right? So the next one is going to be 1 over 2 minus 1 over 5. And so on. The last term, instead of this, I'm going to write 1 over Fn minus 1, 1 over Fn plus 1. Now you can see there are some terms that are going to get cancelled. So it's probably, so the first terms are from 1 to n minus 1, right? The second terms is from 3 to n plus 1. So basically you see overlapping terms is from 3 to n minus 1. So what we are left is here non-overlapping terms. Non-overlapping terms. So first and second, 1 plus 1 over 1, and then minus the last two. So the last two will be in the negative form. So 1 over fn minus 1 over fn plus 1. Or that's 2 minus 1 over fn minus 1 over fn plus 1. So this expression for this sum is much easier. So you need to know only 2 Fibonacci terms to get the entire sum. So instead of doing this sum of all these fractions and then doing common denominator, you can just do this and then get the result for this one. So this is the simplest form. So there is an explicit formula for Fibonacci numbers. You can just plug it and then you get the general formula for Fn. But the idea is to rewrite the general term, this one, as this. When you rewrite it, you will see that there are a lot of terms that cancel each other, and then you are left with this one only.